Okay, testing the second zinc anode using cement as the binder. The ratio of the mix for that cell is here. I have 5.5 grams of zinc powder, 2.55 grams of graphite, 4 grams of carbon, 6 grams of cement and 8 grams of water to mix that cell. We're on the 200 range there in ohms. And I can press hard, but it seems to be a bit brittle and delicate. See how that thing makes notches in the surface? If I hold it flat, you can sort of get a bit better, around about there, about 41 ohms. So I'm not sure how that's going to go. Maybe the zinc powder dissolves and wrecks the cell, not sure. It did take 20 tries to make that cathode, so we're only up to 2 now. Changed the content of the water back to 8, cement to 6. This 8 grams of water seemed to be a bit too much for this one for some reason. Maybe the zinc hexacyanopyrate sucked up too much water. Yeah, because I used extra cement here. 1 gram less of carbon on this one compared to that one. Graphite's the same amount, and the zinc powder was up by 2 grams. Alright, I'll set up the cell and see what happens. Okay, it's bubbling. Well, it was. I heard it sucking in all the water. So let's connect the data logger to it. Okay, we have 0 voltage at the moment, so I'll set up a charge. I'll move the pad a bit closer. So the pad to the zinc plate's around about 10 mil apart in the electrolyte, no separator. Same voltage for the charge, 2.5. Set monitor. We'll try an hour's charge for the first up. Connecting. Okay, we're only at 600 milliamps, so not as good as the other one. That was about 1 amp at the same voltage. But sort of matched the zinc plate. I touched that glue and it fell off around there, so the electrolyte got under there. Oh, it's a bit blurry. Focus. So electrolyte does still creep up under that. That was just heat gun glue, so that's not that great on metals. Alright, bit of luck. This one performs a bit better than the last anode. Okay, first charge for the new anode. 3 hours and 20 minutes. I don't know what happened to the hour. I was busy. So disconnecting. We're 2.2. We're normally about 2.3 after a connection. I mean a disconnect, but it drops rapidly. I can hear it bubbling. The other one never used to bubble. So we're at 2 volts. We're still alright. It's gonna drop quickly. So 20 milliamps again. Starting test. Oh, we had a major drop then, but we'll see how it goes. It's the first charge. The cell could already be dissolving. Alright, we'll let that go and I'll get back. Okay, back with the first run. 1 hour and 58 minutes it ran for. 39 milliamp hours and 38 milliwatt hours. Okay, there. Right, so the plate's looking okay. That's the first run. So it's not dissolving, what I can see. So I'll leave it in overnight and see what happens in the morning. How's that even got voltage? Weird. Okay, quick update to the anode. We're only about 35 milliamp hours on that anode. Little cement one down in there somewhere. It's only about that big there and about that wide, so it's not the full length of that. And the results, I'm doing the update because here on this run where it ran for 2 hours and 32 minutes, the day before this run it was charged up for 6 hours and then the power went out, so I couldn't get to discharge it. So the next day elapsed and I put a charge for another 6 hours and 25 on it, and it ran okay. So I'm not sure if it needs a longer charge, but today's charge is 7 hours and 30 minutes, and we're not gonna run for much longer. It's at 0.6 now, so we'll probably just get 2 hours, so not sure. The good news is it hasn't dissolved, so that formula's alright, but it's not very high in surface area. And I have a new one out the back forming. I put some zinc oxide in it, and I'm hoping with the zinc oxide it will dissolve out and leave little nano pores throughout the carbon, and then the zinc in the zincate will bind in the little holes and gaps what the zinc oxide leave. Maybe, it's just a thought. So I've got this one drying, slightly different. I put some more carbon by 1 gram, 6 grams of cement, 8 grams of water, 3 grams of graphite instead of 2.55 like in that one. Graphite 2.55. And the other day at work when I was unpacking some stuff, see this was in a TV box. Calcium chloride in a little satchel used to soak up the moisture. I'm not sure if there's a mixture of something else in there, but it feels like a gel. But the interesting thing is this side here, that's where the air and the moisture go into it. So it's dry on the outside here, but this might make a good separator for a air battery, perhaps. That would seal your electrolyte in there, and I think the air and moisture can pass through there. Maybe, just a thought. I thought I'd keep them anyway, because if it's pure calcium chloride, that's cheap because I got it for free. Okay, pretty close to 2.5 hours, so maybe the cell's just increased in its power a little bit. Not much though. I'll keep testing for another 10 or so, or until that new briquette is ready. Second anode test results. We started off on the first charge as a cell was 39 milliamp hours, 3 hours and 20 minutes on charge, and run time was 2 hours and 32 minutes. And all the way down to 20. So for a 7.5 hour charge, ran for 3 hours, average voltage 61 milliamp hours and 52 milliwatt hours. So that's the results over 20 days. and happy with the results. That's anode testing. It's held up, no damage. Looks like there's some pauses. I think that's a bit of paper, the tracing paper stuck in that piece there. Okay, so that's that one. I gave it a further 3 charges with the zinc plate in comparison. I didn't clean it, it was sort of in that state before putting it in 3 days ago. And the results for the zinc plate, 8-hour charge, 84 milliamp hours. So it was a slight increase. It ran for 4 hours, that's the highest it's run. That started to decline today here. So it's somewhat not that stable with the zinc plate now. That could be the cathode. Cathode's had about 70 charges. That's still holding up well. Just that bit of graphite looks a bit sus on the electrolyte boundary. I solved the connector problem by putting a piece of graphite plate there, and it seems to be working okay. For now, maybe it's not as good as a contact from copper, but it's not too bad. So I've got a new cell design for the anode. Going to use 2 grams of zinc oxide, 2 grams of powder, 3 graphite, 5 carbons, and 6 grams of cement for the binder, and 8 grams of water. And that produced this thing. That's on the 200 range. This little pad here. I'm hoping that the zinc oxide will dissolve out and leave micro pauses for zinc buildup and plating. So it's around about over that distance. A wobble, depends how tight you hold it. I'm just holding it pretty firm. So it's down to 12.9 ohms, something like that for resistance. If you stick it lightly there, you don't sort of get it. You get a better result on the flatter surface. So, well, hopefully this one's not too bad. So I'll soak it in electrolyte now. Seems like there's a crack there, and oh yeah, I can see it bending. Got a little mesh of nickel wire I made in this. So I'll just that's it. Oh yeah, hang on, we can do a star that next video. Alright, so that's the result of that last formula for the negative cell, the anode. And catch you on the next video.